In this video, I'm going to introduce the container data types in Python. The first one is going to be the list. List is a collection of different data types. It can have primitive data types like integers, floats, strings, etc. But it can also contain other complex data types. It's a sequence, so it can be indexed like string data types. Lists are mutable data structure, so we can modify an individual element inside a list. Lists are also iterable, so we can execute for loop or while loop on those lists. Let's take a look at how we can create a list. There are multiple ways to create a list. We can create a list using square bracket notation. For example, here I'm creating a list with elements 1, 2, 3, 4 and 5. Now if I print this list, you can see that it prints all the elements inside the square brackets. We can create an empty list using empty square brackets. I can also use a list function to create an empty list. We can create a list of either number data types, or we can also create a list of any string data type. For example, let's create a list of fruits. It contains apple, orange, and banana. Let's print it. List can also contain multiple data types. It's not restricted to have only one data type element in a list. I can create a list with mixed data type. Here it contains elements 1, 2, a boolean element true, a string element banana, and another boolean element. We can also nest one list inside another list. So if I want to create a nested list, I can create it like this. This looks very much like a matrix in mathematics. If I check the data type of this list, you can see that it's a class list. We can use the list function to create another list from any other sequence data types. For example, if I want to create a list from a range object, then I can create it like this. Here I have passed range 5, and this creates a list with elements 0 to 4. I can also pass the starting position and the ending position to this range object, and it will create a list accordingly. As we know from previous video, that strings are sequence of characters. So I can pass a string into this list function, and it will return me a list with all the characters of a string. If I multiply a list by any number, then it will repeat those elements that many times. So here I multiply a list with only one element 10 times, and it creates a new list with 10 zeros. Similar to string data type, we can also use the indexing on list data types. Lists are also sequences of other data types, so when we select a specific index item, it will return an element at that index position. Let's create our numbers list with elements 1 to 5. Now if I print numbers 0, it prints 1. If I check numbers 3, it prints 4. I can also use the negative indices like we did for string data types. So if I check numbers -1, it returns the last element of the list, which is number 5. As I mentioned, lists are mutable data structures. So I can modify an element of a list. If I modify the last element to, let's say, 500, and now if I check numbers list, you can see that last element has been replaced with value 500. We can find a length of a list using len function. Len numbers, and it returns 5. Similar to list, if we try to access an index that doesn't exist in a list, then it throws index error. If I try to check my list of numbers at index position 6, it throws index error, list index out of range. To avoid that, we can definitely make use of this len function. The last element will always have the index position as length of list minus 1. So numbers, length of numbers minus 1 will return the last element of the numbers list. Let's get back our nested list we created earlier on. If I want to get the inner list, I can use the same indexing operation, and if I check the first element, it returns me this first nested list. Now if I want to get the second element from this nested list, I can use the index position 1. So nested list 0, 1 will return 2. Similar to string objects, we can slice a list. Slicing operation looks like this. Inside the square bracket, we can specify the start position, the stop position, and we could also specify the steps we want to increment. Let's take some examples of this and it will become clear. Let's create a new numbers list with range object 1 to 11. This will create a list with elements 1 to 10. If I check numbers 4, colon 6, this will get me the elements starting from index position 4, which is number 5, up to the index position 6, which is number 7. The stop position element is not included in the output list. So if I run this, I get new list with elements 5 and 6. If we don't specify the start position, it will by default start from 0. So if I run numbers colon 5, it will return me similar output as numbers 0 colon 5. It returns the first 5 elements up to the index position 5. If I don't specify the end position, it will by default go up to the end of the list. So if I write numbers 5 colon, it will return all the list elements starting from index position 5 up to the end of the list. So it returns elements 6 up to 10. By default, the step value is 1. If I specify the step value as 2, it returns every other element. If I want to get only the even numbers, I can specify the starting position as 1, and as a step value, I can specify 2. This returns a list with all the even numbers from the original list. If I want to get all the elements in the reverse order, then I can specify the step as -1. Numbers colon colon -1 will return me a list with all the elements in the reverse order. We can join two lists using plus operator. So if I define list 1 with elements 1, 2, and 3, and I create new list 2 with elements 4, 5, and 6, If I perform list 1 plus list 2, it returns a new list with elements 1 to 6. In Python, we can unpack a list. This may be different from other programming languages. If you have background in JavaScript, then you may find it similar to destructuring assignment. If I have a list with two elements, 1 and 2, I can assign these two elements to two separate variables. I can write something like this: a comma b equals list, and this will assign variable a with a value 1 and variable b with value 2. Let's print them to make sure. And yes, they have the values 1 and 2. We can iterate over list using simple for loops. Let's remind ourselves what we had in the fruits list. Now I can iterate through this list using for loop. For fruit in fruits, print fruit. This will simply assign each element into this local variable fruit, and inside the loop we are simply printing that fruit. So first it will assign the apple inside this fruit variable, and it will print apple. In the next iteration, it will assign orange into this fruit variable, and it will print orange. And this way it will iterate through all the elements of a list. We have already seen how we can iterate through a range object. Similar to that, we can iterate through numbers list. If I have numbers list with elements 1, 2, 3, 4 and 5, I can write a loop to iterate through all the elements like this. If we also want to keep track of the index position of each element of a list, then we can use enumerate function. Let's create a new list, cities, with elements New York, London, New Delhi, and Sydney. If I want to print the index position along with the city name, then I can write for index, city in enumerate cities. And inside the loop, we can simply print city with index, and we can write the city name. If I run this, it prints this output. There are some built-in functions or methods on this list data types. When I say functions or methods, they are very similar to each other. Methods are invoked using dot notation. So if I have numbers list with elements 1, 2, and 3, if I want to insert a new element in this list, I can use the insert method. In order to get more information on this insert method, I can use the built-in function help. Help numbers.insert, and I can see little bit of document on this insert method. It takes index position and the object we want to insert. So let's insert 0 at the first position. I can write numbers.insert 0, 0. If I check numbers list, it has elements 0 to 3. If I want to insert the element at the fifth position, then I can write numbers.insert index position 4, and the value I want to insert is 400. If I check our numbers list, then it has 5 elements. We can append an element at the end using append method. If I perform numbers dot append 500. If I check our numbers list, then it has 500 at the end. Now I can pop out the last element using pop operation. This will remove the last element and return it. Numbers.pop, and I get back 500. I can also assign the last element to a variable. If we check our numbers list, it has these 5 elements and the last element is 400. If I write last equals numbers.pop, and now if I print the last element, it prints 400. If I check our numbers list, last element 400 has been removed. Let's recreate our numbers list. Numbers equals 0, 1, 200 and 3. If I want to remove an item from specific index position, then I can specify that in the pop method. By default, it removes the last element, but if I specify an index, then it will remove that index position element. Numbers.pop 2. It will remove this 200 from the numbers list. Now if I print this numbers list, it has elements 0, 1 and 3. We could also remove an element using del operator. This operator only removes that item but does not return it. If I create our numbers list with elements 0, 1, 2 and 300, if I write del numbers -1, then it will remove this last element, which is 300. If I print our numbers list, then you can see that it has elements 0, 1 and 2. We can add elements of another list using plus operator. We have seen that if we add to list, then it returns a new list with all the elements inside that list. But if we want to modify an existing list with elements of another list, then we can use extend method. If I create numbers list with elements 1, 2 and 3, and if I create other list with elements 4, 5 and 6, I can write numbers.extend with others. This will add all the elements from the others list into this numbers list. Now if I check this numbers list, it has elements 1 to 6. We can also use remove method to remove specific element from a list. If I have numbers list with elements 1, 2 and 3, 400, 5 and 400. If I write numbers.remove 400, then it removes the first occurrence of this value. So this one can be useful when we want to remove an item based on their value, not based on their index. If I check numbers, then the first occurrence of 400 has been removed from the list. We can compare list using double equals. If I have numbers list with elements 1, 2 and 3, and if I create another list using range function 1 to 4, this also creates the same elements 1 to 3. Let's print both this list, print numbers and print others. Now if I check numbers equals others, then it returns true. But if I check ID of these two lists, then you can see that both these lists are stored in a different locations. So those lists are basically different, but because they have the same elements, this equals operation returns true. If two lists are not equal, then it will return false. We can repeat the same elements of a list by multiplying it by any number. We have seen this earlier with only single element. Let's check this operation. If I have numbers list with elements 1, 2, 3, and now if I multiply this list by 2, then it returns a new list with elements repeated 2 times. We can find sum of all the numbers from a list using sum function. I can also use min function to find the minimum number from the given list. And similarly, I can use the max function to find the maximum. We can create a string out of a list by joining all the elements using some separator. If we recall our fruits list, it has elements apple, orange, and banana. I can create a string which separates these three fruits using comma. I can write something like this. I'm using join method and I'm passing this list inside this join method. It returns apple, orange, and banana. If I have a string which has some kind of delimiter, then I can use the split method to split the string elements based on that delimiter. Here it returns all the three colors in three separate elements of a list. Similarly, if I have any other separator, then I can specify that separator in this split method. We can also search for an element inside a list. There are multiple ways to search an element. If I create our fruits list again, fruits with elements apple, orange, and banana. Now if I want to get an index of banana, then I can use fruits.index of banana. It returns 2. If the element doesn't exist in the list, then it throws a value error. If I try to check for pineapple inside this fruits list, then you can see that it throws a value error. Pineapple is not in list. Python errors are usually very readable and you can easily understand what they means. Here it couldn't find this pineapple string in our fruits list. There is another way to find an element in the list using in operator. I can write apple in fruits and it returns true. If I write pineapple in fruits, then it returns false. We could also use this operator to find the index position of specific element defensively. I can write position equals fruits.index of pineapple if pineapple in fruits. Else I can return some other number like -1. If I print the position, then you can see that this returns -1. We can also sort elements of a list using sorted function. Let's check the documentation for this sorted function. This sorted function takes any iterable and it also has this reverse keyword argument with a default value of false. In the description you can see that it returns a new list containing all items from the iterable in ascending order. If I use it on our fruits list, then you can see that it returns a new list with all the strings arranged in the alphabetical order. If I check my original list, this has not been modified. If I want to sort this list in the reverse order, then I can pass the reverse attribute. Sorted fruits with a reverse attribute as true. And this returns a new list with all the fruits sorted in the reverse order. I can also use the sort method to modify the list in place. So if I write fruits.sort, this will sort our original fruits list. So now our fruits list has been modified. Similar to sorted function, this sort method also takes reverse attribute, which has the default value of false. If I recreate our fruits list with elements apple, orange, and banana, now if I try to sort this list using fruits.sort and I pass the keyword argument reverse equals true, if I print our fruits list, you can see that it has modified our original list into reverse order. We can perform the same kind of operations on numbers list. So if I have numbers list with elements 12, 5, 7 and 3, I can sort them using sorted functions. I can also sort them in place by using numbers.sort. And as expected, this modifies the original numbers list. We can also clear all the elements of a list using clear function. So here I have this numbers list. If I run numbers.clear, and now if I try to print numbers, you can see that it returns an empty list. In Python, there is even an elegant way to create list. We can create list using list comprehensions. It looks like this. We write for expression for element in list, and before that we write an expression. This expression will define what elements we want in the output list. Let's check out a practical example of this. If I have fruits list with elements apple, orange, and banana, if I want to get the first character of each of these elements from this fruits list, then in that case I will first create an empty list. Then I will iterate through this fruits list for fruit in fruits, and I can append the first element of each fruit into this list. If I print this list, you can see that it returns the expected output. But using list comprehensions, we can achieve all of this in just single line of code. I have to write square bracket, and in the expression, I want the first character, so I will write fruit 0 for fruit in fruits. If I run this, you can see that it returns the same output. Similarly, if I want to get the squares of each of the numbers from a list, I can write list comprehension. If I have numbers list with elements 1, 2, 3, 4, 5, then I can get squares of each of these numbers. First, I have to write for expression for number in numbers, and in the output list I want square of these numbers, so I write number multiplied by number. And if I print this, then you can see that it has the squares of each number. I can also include an if expression in my list comprehension. If I want squares of only even numbers, then I can write for number in numbers, and for the expression I can write number multiplied by number. I can include the if block to filter out only the even numbers. After this for expression, I can write if number modulo 2 equals 0. This will filter out all the even numbers and then square those numbers. Let's assign it to a variable even squares, and let's also print it. You can see that it only prints the square of 2 and 4. This way, list comprehensions can provide an elegant solution to a complex looking problem. But list comprehensions can also add to the complexity of the code. So I would recommend that you should use list comprehension only for this kind of simple expressions. Don't overuse them in complicated looking list comprehensions.